Hey, space enthusiasts! Ever wonder about the mysteries hidden within our very own cosmic backyard? Well, buckle up, because today we're diving deep into the solar system with 10 mind-blowing facts that will leave you starry-eyed. Ten mind-blowing facts you never knew about the solar system. From planets with diamond rain to moons with geysers that shoot ice, our solar system is packed with wonders. So grab your favorite space snacks and get ready for a cosmic adventure. Number 1. The biggest volcano in the solar system. You think Mount Everest is big? Think again. Olympus Mons on Mars is a colossal shield volcano, towering at a staggering 16 miles high. That's nearly 3 times taller than Mount Everest. It's a truly mind-boggling fact. Here's a breakdown of what makes it so impressive. Size. It stands about 16 miles, 25 kilometers high, which is almost 3 times the height of Mount Everest above sea level. Its base is about 374 miles, 601 kilometers, in diameter, roughly the size of the state of Arizona. Type. It's a shield volcano formed by relatively fluid lava flows spreading out over a long period, creating a broad, gently sloping structure. Formation. Scientists believe Olympus Mons grew over billions of years due to repeated eruptions of lava. Mars's lack of plate tectonics allowed the volcano to remain stationary over a hot spot in the mantle, enabling it to grow to such immense proportions. Why is this so significant? Scale. It gives us a sense of the sheer scale of geological processes that can occur on other planets. Martian history. Studying Olympus. Mons helps us understand Mars' volcanic history and its internal structure. Comparison to Earth. Comparing it to volcanoes on Earth provides insights into the different geological forces that shape planets. Olympus Mons is a testament to the incredible diversity and power of nature, even beyond our own planet. It's a fantastic example of why exploring space is so important. We continue to discover things that challenge our understanding of the universe. Number 2. A diamond planet. Forget gold. On the ice giant Uranus, diamonds might be raining down. Extreme pressure and temperatures can transform carbon into solid diamonds, creating a truly unique and valuable downpour. That's a great summary of the diamond rain theory on Uranus and Neptune. Let's break down why this is thought to happen. Atmospheric composition. Both Uranus and Neptune have atmospheres rich in methane, a molecule composed of carbon and hydrogen. Extreme conditions. Deeper within these gas giants, the pressure and temperature increase dramatically. The pressure can reach millions of times that of Earth's atmosphere, and the temperatures can climb to thousands of degrees Celsius. Methane breakdown. Under these extreme conditions, the methane molecules are thought to break down. The hydrogen separates from the carbon. Diamond formation. The freed carbon atoms are then compressed by the immense pressure. This compression forces the carbon atoms to bond together in a crystalline lattice structure, forming diamonds. Rain. These newly formed diamond crystals, being denser than the surrounding atmosphere, would then rain down through the planet's interior, potentially sinking towards the core. Why is this different from a diamond planet like 55 Cancri E? Formation mechanism. On Uranus and Neptune, the diamonds are believed to form from the breakdown of methane in the atmosphere. In the case of a diamond planet, like 55 Cancri E, the entire planet is theorized to have a significantly higher proportion of carbon from the start, leading to the possibility of a large diamond core or mantle. Scale. The diamond rain on Uranus and Neptune is a process occurring within the atmosphere. A diamond planet suggests a planet where a substantial portion of its mass is composed of diamond. Evidence and research. Laboratory experiments. Scientists have conducted experiments recreating the conditions inside Uranus and Neptune using powerful lasers to simulate the shock waves and pressures. These experiments have provided evidence supporting the idea that diamonds can form from methane under these conditions. Computational models. Computer models of the interiors of Uranus and Neptune also support the possibility of diamond formation and rain. It's important to note, this is still a theory, although a well-supported one. We don't have direct observational evidence of diamonds raining inside Uranus and Neptune. However, the combination of laboratory experiments and computational models makes it a compelling and plausible explanation for the behavior of carbon under these extreme conditions. The idea of diamond rain adds another layer of fascination to these ice giants, showcasing the extreme and diverse processes that can occur in our solar system and beyond. Number 3. The longest canyon. The Grand Canyon is impressive, but it's got nothing on Valles Marineris on Mars. This massive canyon system is over 2,500 miles long, making it long enough to stretch across the entire United States. You're bringing up another incredible feature of Mars. Valles Marineris is truly a colossal canyon system that dwarfs anything we have on Earth. Here's a closer look at this Martian wonder. Scale. Valles Marineris stretches for over 2,500 miles, 4,000 kilometers, across the surface of Mars. To put that in perspective, it's about the same length as the entire United States. It's also up to 120 miles, 200 kilometers, wide, and reaches depths of up to 4 miles, 7 kilometers. Comparison to the Grand Canyon. While the Grand Canyon is impressive, Valles Marineris is on a completely different scale. It's about 10 times longer, 20 times wider, and much deeper than the Grand Canyon. Formation. The exact formation of Valles Marineris is still debated, but the leading theory suggests it's primarily a tectonic feature. It's believed to have formed due to the stretching and cracking of the Martian crust, likely related to the formation of the Tharsis Bulge, a large volcanic region to the west. Subsequent processes like erosion and landslides have further shaped the canyon system. Why is Valles Marineris important for scientific study? Geological history. Studying Valles Marineris provides valuable insights into the geological history of Mars, including its tectonic activity, volcanic processes, and past presence of water. Potential for past life. Some scientists believe that Valles Marineris may have once held lakes or even a larger body of water, making it a potential area to search for evidence of past life on Mars. Understanding planetary evolution. Comparing Valles Marineris to similar features on Earth and other planets helps us understand the different forces that shape planetary surfaces. Valles Marineris is a testament to the powerful geological forces that have shaped Mars over billions of years. Its sheer size and complexity make it a truly awe-inspiring feature and a key target for future Martian exploration. Number 4. A moon with geysers. Saturn's moon. Enceladus is a tiny ice ball, but it packs a powerful punch. Cryovolcanoes erupt from its surface, shooting geysers of water ice hundreds of miles into space. Enceladus is a small but incredibly fascinating moon of Saturn, and you're right to bring it up. It's captured the attention of scientists because it has some unique features that make it a prime candidate in the search for extraterrestrial life. Here's a breakdown of what makes Enceladus so special. Icy surface. Enceladus has a bright, icy surface that reflects almost 100% of the sunlight that hits it, making it one of the most reflective objects in our solar system. This gives it a very cold surface temperature, around -200 degrees Celsius, -330 degrees Fahrenheit. Geysers and plumes. The most remarkable feature of Enceladus is the presence of geysers erupting from its south pole. These geysers shoot plumes of water vapor, ice particles, and simple organic molecules hundreds of miles into space. Subsurface ocean. These plumes provide strong evidence for the existence of a subsurface ocean of liquid water beneath Enceladus's icy shell. This ocean is thought to be salty and may even have hydrothermal vents on its floor, similar to those found on Earth's ocean floor. Tidal heating. The source of the heat that keeps the ocean liquid is believed to be tidal heating. As Enceladus orbits Saturn, the planet's gravity exerts tidal forces on the Moon, causing it to flex and generate heat within its interior. Why is Enceladus important in the search for life? Liquid water. Liquid water is considered essential for life as we know it. The presence of a subsurface ocean on Enceladus makes it a potentially habitable environment. Organic molecules. The detection of simple organic molecules in the plumes suggests the possibility of more complex organic chemistry occurring within the ocean. Hydrothermal vents. Hydrothermal vents on Earth provide energy and chemical nutrients that support thriving ecosystems in the deep ocean. If similar vents exist on Enceladus, they could provide the energy needed for life to exist. Enceladus is a key target for future space missions aimed at searching for extraterrestrial life. Studying its plumes and potentially even sending a probe to explore its subsurface ocean could provide valuable insights into the possibility of life beyond Earth. Number 5. The hottest planet. You might think Mercury is the hottest planet, but it's actually Venus. Its thick atmosphere traps heat, creating a scorching surface temperature that could melt lead. You're absolutely correct. It's a common misconception that Mercury, being closest to the Sun, is the hottest planet. However, Venus holds the title of the hottest planet in our solar system. Here's why. Runaway greenhouse effect. Venus has an extremely dense atmosphere composed primarily of carbon dioxide CO2. This thick atmosphere traps heat incredibly efficiently, creating a runaway greenhouse effect. Sunlight passes through the atmosphere and warms the surface, but the heat is then trapped by the CO2, preventing it from escaping back into space. Surface temperature. This intense greenhouse effect results in a scorching surface temperature of around 465 degrees Celsius, 870 degrees Fahrenheit. This is hot enough to melt lead. Comparison to Mercury. While Mercury is closer to the Sun, it has a very thin atmosphere. This means it can't retain heat effectively. Mercury experiences extreme temperature swings between its day and night sides. While its daytime side can get very hot, its nighttime side is incredibly cold. Venus, on the other hand, has a much more uniform temperature across its surface due to its thick atmosphere. Key takeaways about Venus's heat. Constant high temperature. Unlike Mercury, which has extreme temperature variations, Venus maintains a consistently high temperature across its entire surface, day and night. Hostile environment. The extreme heat, combined with the dense, toxic atmosphere and sulfuric acid clouds, makes Venus a very hostile environment for life as we know it. Lessons for Earth. Studying Venus's runaway greenhouse effect provides valuable insights into the potential consequences of climate change on Earth. Venus serves as a stark reminder of the powerful influence of atmospheric composition on a planet's temperature. It's a fascinating and important object of study for understanding planetary climates and the potential for habitability. Number 6. A day longer than a year. Venus takes longer to rotate on its axis than it does to orbit the Sun. That means a day on Venus is actually longer than a year. You're hitting on a truly bizarre and fascinating aspect of Venus. It's one of the most striking differences between Venus and Earth. On Venus, a solar day, the time it takes for the sun to appear in the same position in the sky, is longer than its orbital period, the time it takes to complete one orbit around the sun. Here's how it breaks down. Rotation. Venus rotates incredibly slowly on its axis. One rotation takes about 243 Earth days. This is the slowest rotation of any planet in our solar system. Orbit. Venus orbits the Sun relatively quickly, completing one orbit in about 225 Earth days. This means that a day on Venus, from sunrise to sunrise, is longer than a year on Venus. Why does Venus rotate so slowly? The exact reasons for Venus's slow and unusual rotation are still debated among scientists. Some theories include early collision. A massive collision with another celestial body early in Venus's history could have significantly altered its rotation. Atmospheric effects. The dense atmosphere of Venus could be interacting with the planet's rotation in complex ways, slowing it down over time. Another unusual aspect of Venus's rotation: retrograde rotation. Venus rotates in the opposite direction compared to most other planets in our solar system, including Earth. This means that on Venus, the sun rises in the west and sets in the east. What are the implications of this for Venus? Surface conditions. The slow rotation contributes to the planet's extremely hot and uniform surface temperature, as there is little variation between day and night. Magnetic field. Venus has a very weak magnetic field, which may be related to its slow rotation. The fact that a day is longer than a year on Venus is a truly mind-boggling concept that highlights the diverse and sometimes unexpected characteristics of planets in our solar system. Number 7. The most moons. Jupiter is the undisputed king of moons, with a whopping 79 confirmed moons orbiting it. That's more moons than any other planet in our solar system. You're right to focus on this. It's a fascinating fact that highlights the complex dynamics of our solar system. For a long time, Jupiter held the crown for the planet with the most moons. However, recent discoveries have revealed that Saturn is now the planet with the most confirmed moons in our solar system. As of late 2023, Saturn has a staggering 146 confirmed moons. This number is constantly being updated as astronomers continue to discover and confirm new moons. Here's a bit more about this lunar abundance. Variety of moons. Saturn's moons come in a wide range of sizes and shapes. Some are large like Titan, the second largest moon in the solar system, while others are tiny, only a few kilometers across. Ring interactions. Many of Saturn's smaller moons interact with its famous rings, shaping and sculpting their intricate structure. These moons are sometimes called shepherd moons because they help to confine the ring particles. Formation. Theories. The origin of Saturn's numerous moons is still a topic of research. Some may have formed alongside Saturn from the protoplanetary disk, while others may have been captured later. Why is this important? Understanding planetary formation. Studying the moons of gas giants like Saturn helps us understand how these planets and their satellite systems formed. Potential for habitability. Some of Saturn's moons, like Enceladus and Titan, have features that make them potentially habitable environments, such as subsurface oceans and atmospheres. Gravitational dynamics. The complex gravitational interactions between Saturn and its many moons provide valuable insights into celestial mechanics. Saturn's impressive collection of moons makes it a truly fascinating system within our solar system. It's a testament to the diverse and dynamic nature of the cosmos, and a reminder that there's still much to discover. Number 8. A great red spot. Jupiter's Great Red Spot is a massive storm that has been raging for centuries. It's so big that 3 Earths could fit inside it. You're bringing up one of the most iconic and enduring features in our solar system. Jupiter's Great Red Spot is a massive storm that has captivated astronomers for centuries. Here's a breakdown of this giant atmospheric phenomenon. What is it? The Great Red Spot is a persistent high-pressure region in Jupiter's atmosphere, producing an anticyclonic storm, rotating in the opposite direction to hurricanes on Earth. It's essentially a giant, swirling mass of gas. Size? It's the largest known storm in our solar system. At its largest, it was estimated to be about 3 times the diameter of Earth. However, it has been shrinking in recent decades. Today, it's still large enough to swallow Earth whole. Duration. Observations suggest that the Great Red Spot has been raging for at least 190 years, and possibly much longer. Some early observations from the 17th century may have depicted it, meaning it could have existed for over 350 years. Winds. Winds inside the Great Red Spot can reach speeds of up to 430 kilometers per hour, 270 miles per hour. Why is it red? The exact cause of the Great Red Spot's reddish color is still a mystery. Scientists suspect that it may be due to chemical compounds like sulfur, phosphorus, or complex organic molecules being lifted to higher altitudes in the atmosphere and then altered by ultraviolet radiation from the sun. Why is it shrinking? Observations over the past century have shown that the Great Red Spot is gradually shrinking. While the exact reasons for this are not fully understood, some theories suggest that changes in Jupiter's atmospheric jet streams may be affecting the storm's dynamics. Why is the Great Red Spot important for scientific study? Atmospheric dynamics. Studying the Great Red Spot helps scientists understand the complex atmospheric dynamics of gas giant planets. Long-term weather patterns. Its long lifespan provides a unique opportunity to study long-term weather patterns on a scale far greater than anything we experience on Earth. Comparison to Earth storms. Comparing the Great Red Spot to storms on Earth helps us understand the fundamental principles of atmospheric phenomena. The Great Red Spot is a truly remarkable feature that continues to fascinate and intrigue scientists. It's a testament to the powerful forces at play in the atmospheres of gas giant planets. Number 9. Rings of ice and rock. Saturn's iconic rings are made up of billions of pieces of ice and rock, ranging in size from dust grains to house-sized chunks. You're referring to one of the most spectacular sights in our solar system, Saturn's magnificent rings. They are a truly unique and awe-inspiring feature. Here's a breakdown of what makes Saturn's rings so special. Composition. Saturn's rings are primarily made up of countless particles of water ice, ranging in size from tiny dust grains to chunks several meters across. There are also some rocky fragments mixed in. Structure. The rings are not solid, but rather a vast collection of individual particles orbiting Saturn. They are incredibly wide, spanning hundreds of thousands of kilometers, but surprisingly thin, typically only a few tens of meters thick. Divisions and gaps. The rings are divided into several distinct rings, labeled alphabetically in the order they were discovered: A, B, C, D, E, F, G. These rings are separated by gaps, the most prominent being the Cassini division, a 4,800-kilometer wide gap between the A and B rings. These gaps are often caused by the gravitational influence of Saturn's moons. Shepherd moons. Small moons, called shepherd moons, orbit near the edges of some rings and help to keep them defined. Their gravity confines the ring particles and prevents them from spreading out. Why are the rings important for scientific study? Origin. The origin of Saturn's rings is still a topic of debate. Some theories suggest they formed from the breakup of a moon or a comet, while others propose they are remnants from the planet's formation. Dynamics. Studying the rings helps scientists understand the complex gravitational interactions between planets, moons, and ring particles. Analogies to other systems. The processes that shape Saturn's rings may be similar to those that occur in other astrophysical systems, such as protoplanetary disks around young stars. While Saturn's rings are the most prominent and easily visible, other gas giants in our solar system also have ring systems, although much fainter. Jupiter. Jupiter's rings are faint and dusty. Uranus. Uranus has a system of narrow, dark rings. Neptune. Neptune's rings are also faint and clumpy. Saturn's rings are a truly remarkable feature, a testament to the intricate and beautiful workings of the universe. They continue to be a source of scientific discovery and wonder. Number 10. The Kuiper Belt. Beyond Neptune lies the Kuiper Belt, a vast region of icy objects, including dwarf planets like Pluto. It's like a cosmic graveyard of leftover material from the formation of our solar system. You're talking about a fascinating region at the outer edges of our solar system. The Kuiper Belt is a vast and icy realm that holds many secrets about the formation and evolution of our planetary system. Here's a summary of what the Kuiper Belt is. Location. It's a region beyond the orbit of Neptune, extending from about 30 to 55 astronomical units, AU, from the Sun. 1 AU is the distance between the Earth and the Sun. Composition. It's populated by a vast number of icy bodies, often referred to as Kuiper Belt objects, KBOs, or trans-Neptunian objects, TNOs. These objects are composed of ice, water, methane, ammonia, and rock. Size and shape. The Kuiper Belt is a donut-shaped region, much larger and more massive than the asteroid belt between Mars and Jupiter. Dwarf planets. Several dwarf planets reside within the Kuiper Belt, the most famous being Pluto. Other notable dwarf planets include Eris, Makemake, and Haumea. Source of comets. The Kuiper Belt is thought to be the source of many short-period comets, which have orbital periods of less than 200 years. Why is the Kuiper Belt important for scientific study? Remnants of solar system formation. The KBOs are thought to be remnants from the early solar system, providing valuable clues about the conditions and processes that led to the formation of planets. Understanding planetary migration. Studying the Kuiper Belt helps scientists understand how the giant planets in our solar system migrated to their current positions. Potential for other objects. Scientists believe there may be many more undiscovered objects in the Kuiper Belt, including potentially larger bodies. New Horizons mission. The NASA New Horizons mission provided valuable insights into the Kuiper Belt when it flew past Pluto in 2015 and then Arrokoth, a KBO, in 2019. These flybys provided close-up images and data that have greatly enhanced our understanding of this distant region. The Kuiper Belt is a frontier of exploration in our solar system. It holds valuable information about the past and may even hold clues about the potential for other planetary systems around other stars. So there you have it, 10 mind-blowing facts about our incredible solar system. It's a place of wonder and mystery, and there's still so much we don't know. Keep exploring, keep learning, and never stop being amazed by the universe around us. Thank you for watching.